So in this last video, we're going to talk about math in chem. And mostly, we're going to talk about conversion factors, dimensional analysis, and tracking units. The reason why I'm doing this myself is because I think this is a very important part of all the calculations we're going to do throughout the semester. So I want to make sure you really understand how to do this and have some practice in doing this. And we'll have more practice in class. So what exactly is a conversion factor? Conversion factor is just a way of converting between one set of units and another. If you're talking about different things, if you're going from inches to centimeters like we have here, or if you're going from meters to inches, kilometers to meters, liters to milliliters, any of these ways you have, you need to convert from one to the other. And you can always write these as a factor. So you take the inequality or take the equality and write them as a fraction with one over the numerator and the other one in the denominator. So you can write it like this with 2.54, oops, stop, sorry, in the denominator, or the 2.54 in the numerator. And this is really just algebra, right? You're just taking this equation here and dividing both sides by the other side, and you get the two fractions. So you can write fractions for any of these conversion factors. So you have a meter equals 3.3 feet. You can write that as fractions. If you have gallons, cups, milliliters, you can write all of them as fractions. Then you can use these fractions as conversion factors. And we just went through a couple of those here. And this is used mostly in what's called dimensional analysis. You track the units of your problem as you're going along, and this can help you to determine if your answer is correct. So if you wanted to convert inches to meters, let's say, you start with inches, you want to get to meters, you look for your conversion factors, and you write them as fractions. And when you write them with units like this, you can see which ones are going to cancel. And you can see by the red lines here that which ones are canceling out. So you're canceling your inches, you're left with centimeters, you cancel the centimeters, you're left with meters, and that's what your final answer is. So when you're doing these kinds of problems, the first thing you think about is what you have and what you want. And sometimes even when you're doing a bigger problem in quantum mechanics, in thermodynamics, you have these bigger problems and you know what you have and you know what you want. And if you look at the units first, sometimes you can get a lot of information about where to go and at least get yourself started. So write out your equations in units. So I have this, I want to get to here. So if you want to do that, you realize that you want the have to cancel. So you have to say what conversion factor would allow this to cancel. And then you go look at your conversion factors, and then you can go back and fill in the numbers. So for example, let's see, PET or CT scans, they're given dosages of pharmaceuticals based on body mass. We go in, you say, I weigh 164 pounds, but in science, everything is always in kilograms. That needs to be converted. So what do you have? You have weight in pounds, you need weight in kilograms. You can go look in Google or wherever, you chart in the beginning of the book, and you get the conversion that 1 kilogram is 2.2 pounds. So you can write these as factors or fractions. So then you say, well, what do I have? I have pounds. I want to use which of these fractions such that I can cancel out pounds and I'm left with kilograms. And if you look at these two fractions, you can see which one is going to cancel. And you take your pounds, you multiply it by the fraction that has kilograms divided by pounds, your pounds cancel, you're left with kilograms. So if your units are right, then your answer is probably right. If you multiply by the wrong one, and then you're left with pounds squared per kilogram, and then you know your answer is wrong. And this is going to come up sometimes even in lab. You're going to be doing things and you say, oh, I don't remember which way it goes. I don't remember if it's double or half. If you write your units, then your units will come out and you'll see which way things are going, which way things cancel. And if your units are weird, then you know probably your answer is wrong. So another example would be the Food and Drug Administration recommends that sodium be no more than 24 milligrams per day. What is this mass in pounds? So now this is two steps. You're going from milligrams to grams and then grams to pounds. And we're going to keep track of significant digits for a while. So you have your conversion factors as fractions, and you say, well, which ones do I need? I need to go from milligrams to grams, so I'm going to use the one that's going to cancel the milligrams, and then I'm going to go from grams to pounds, so I'm going to use the one that's going to allow me to cancel out grams and be left with pounds. And then you just substitute your numbers in. 2,400 milligrams times 1 gram per milligram, milligrams cancel, left with grams, times 1 pound per gram, grams cancel, left with pounds. So now you've taken your units from what you had, milligrams, to what you wanted, pounds, and you can see that everything cancels out nicely. So this is called the dimensional analysis or factor conversion method. So you just have to think about what your fractions are and just write them out as fractions. Sometimes you'll see something in percentages. And what a percent really means is that it's out of 100. So if you see 1.9%, you can write it 1.9 grams for every 100 if it's mass percent. You may see volume percent, so that means 1.9 mils out of every 100. So whenever you see a percent, you're going to write it as a base out of 100. The other thing about percentages, and I kind of stress this, kids are resistant to this as well, but this works. If somebody gives you a percent of something, it's the percent over 100 is over of. And if you kind of remember the is over of, so you can say 20% of 125 is 25. And you write it in this fashion here, you can always know which number to plug in and what goes where. So you get a percentage, you write it that way, and then you assume either 100 grams, 100 milligrams, or whatever base unit you're using. So again, just a little practice. So if you're converting from millimeters to from meters to centimeters, these are the fractions you would get. If you say that jewelry is 18% gold, that means it's 8 grams of gold per 100 grams of jewelry. So everything you assume 100-gram basis. 1 gallon of gas costs $3.40. So your fractions again become $3.40 per gallon, or 1 gallon for $3.40. And you'll see some of these problems will come up in Connect. Other problems that you can solve, let's say dosage problems. Again, this is where this comes up a lot. You want to convert to how many grams, milligrams per capsule. So you know how many capsules you have, you know how many milligrams are in a capsule. You can use these converting factors. You make the fractions, you use whatever cancels your units. So in this case, 2 capsules, 250 milligrams per capsule, and you cancel out and you get 500 milligrams. Okay. So this is the same one. Now this is a little bit more complicated. 0.15 milligrams of Synthroid, and if the tablets in stock are in 75 micrograms, how many tablets do you need? So again, you start with what you have. I have micrograms. I need milligrams. I need number of tablets. You write out your equivalencies, write them out as fractions, and start thinking about where you want to go. You're going from milligrams to tablets. So how do you get rid of each one? You want to get rid of milligrams, so you want to pick the one that has milligrams in the bottom. So you're going to multiply by milligrams per gram, and then you're going to be left with the micrograms rather. And then you want to say, well, I want to get from micrograms to tablets. So you want to cancel out the micrograms and have tablets be left. So you want to use this second one here where you have tablets on top and micrograms on the bottom. Then all you have to do is plug in your numbers and everything cancels out nicely, and you tell how many tablets. You got a nice even number, it has the right units, so you know your work is done and you've done it right. What about a conversion factor where you're talking about volumes and cubic meters and liters and things? They get a little bit more complicated, but again, if you follow the units. So you want to convert 5.2 liters of blood to what is the volume in cubic meters. So you know that 1 liter is 1,000 cubic centimeters. 1 centimeter is 10 to the minus 2 meters. So those are your unit factors. But when a unit is raised to the power, the conversion factor must also be raised to that power. So in this case, you're going to convert liters to centimeters cubed, but now you need to convert from centimeters cubed to meters. So when you bring in your conversion, you have to cube that as well. I could see that here. Okay, so now you've cubed the unit as well, and now this is now your answer: 5.2 times 10 to the minus third meters cubed. So again, just following your units. And talking about volume brings us into density. A lot of times, some of the calculations you're going to do are going to involve density, or you're going to be able to use density to get what you need. So density is the mass divided by the volume for any different substance. Objects that all have different densities, and you can put them in water, and you see here the different densities of things. So if something has a greater density of water than water, like lead, it'll sink to the bottom. If you have a smaller density than water, like cork, it'll float on top. Ice is sort of near the top, but it's not quite as dense as water. Water is 1, and then aluminum would be somewhere lower as well, but not as dense as lead. So you can look at different densities and do different calculations and different problems that way. And there's a whole table of all different densities in your textbook, and how they would float or not float on water. This will be similar to the lab that we're going to do. but mostly you're going to take density is equal to mass over volume, and sometimes you're going to need to calculate a mass from someplace else or a volume that you're going to need someplace else, and you can get this by working through your density. So you can use density as a conversion factor. So here we're going to use density as an example of using density as a conversion factor. You're giving 2 teaspoons of cough syrup for a cough. If the syrup has a density of 1.20 grams per mil and there are 5.0 mils in a teaspoon, what is the mass in grams of the cough syrup? So again, we start with what we have. You're given some volume and you're given a density, but you're not really given any mass. So you say, how do I find the mass? And this is where you're going to use density to find the mass. You remember the density equation. Density is equal to mass over volume. Just do a little algebra and you bring the volume up. And density times volume is equal to mass. So you have your density in grams per mil and you have your volume in teaspoons. If you just multiplied that, you'd get a mass, but it would be mass in grams per mil per teaspoon. That wouldn't really give you anything useful, right? So you really need that you have to convert first. So you have to convert your teaspoons to milliliters, and we'll do that next. You're going to write out your conversion factors. They'll either be given or you'll have to look them up, but you write out your conversion factors. And then you can convert from the teaspoons to milliliters. So you take your mass again is equal to density times volume to have your density, but this time you're multiplying by the milliliters per teaspoon. So now your teaspoons cancel, your milliliters cancel, and sorry, milliliters cancel, and then you're left with 12 grams, and then you've solved this using density as a conversion factor. So there are a number of other different units that we can use as conversion factors as well. You remember that we have pairs is 2, a dozen is 12, all these other different numbers, and we'll be doing the mole, which a mole is 6.02 times 10 to the 23rd units, and we'll understand how we can use that as a conversion factor. We will use that to convert between mass and moles in future chapters. And one thing I want to stress here is that throughout this semester, I want you to always write your units. If you always write your units, you can, most of the time, it'll help you get your answer right. So my answer to this is you will show units for all calculations. And I tell my students, resistance is futile. If you don't use units, you will get points marked off, and more than likely you will get some problems wrong that you could have gotten right if you paid attention to your units. So when you come into class, we will be going over more of these problems and calculations involving units and involving some of the other things that you've seen in the other lectures, such as significant digits, scientific notation, and some other kinds of calculations. So some of the things we will be doing on Thursday will involve all these types of calculations. So I'll see you then.